Welcome back. Today we're going to be looking at how to deal with polyatomic ions when writing the formulae for ionic compounds and when to use brackets. Now polyatomic ions are these ones here. So where they have multiple capital letters, that tells us that there's multiple elements in that ion. And sometimes we need to use brackets with them. Now the process for writing the formulae starts the same. So calcium hydroxide is made up of the calcium ion and the hydroxide ion. And we're going to try and balance the charges. So at the moment there's 2 positive charges and 1 negative charge. So we need another negative charge to help them cancel out. So now we've got 2 positive charges and 2 negative charges, which can cancel out to give us an overall neutral compound. Now, to write this formula, we have Ca, which we used once, so we don't need a subscript, but we've got a polyatomic ion that we used twice. Now, if we just wrote this, the 2 only applies to the element before it. So this tells us that there's 2 hydrogens, but we also had 2 oxygens. So if we have multiple polyatomic ions, we're going to use brackets. So to show that we use the OH twice, we have our brackets around it and the 2 goes outside the brackets. Now this 2 applies to this whole thing. So we've got 2 hydroxides, 2 oxygens and 2 H's. So the formula for calcium hydroxide is Ca bracket OH bracket 2. Alright, our next example is copper carbonate. So copper is Cu2 plus, carbonate CO3 2 minus. Again, we're looking at the charges. So copper has a +2 charge, carbonate has a -2 charge. Those charges can cancel out. So we didn't need to write any of those ions multiple times. So for this one, we just have our Cu with no subscript, and then our CO3 with no extra subscript. Now it is important that we do keep that 3 there because it belongs to the oxygen. So carbonate contains 1 carbon and 3 oxygens. We don't want to mess with that. So for copper carbonate, since the charge is cancelled out already and we didn't need multiple polyatomic ions, we don't need brackets. Okay, we'll see how that works with our next example. Iron 3, so Fe3 plus, nitrate, NO3 minus. Looking at the charges, we've got 3 positive charges, so we need 3 negative charges to cancel that out. Whereas nitrate only has 1 negative charge. So what I'm going to do is write this nitrate 3 times. So now we have a total of 3 negative charges that can cancel out the positive 3 charge to give our overall neutral ionic compound. So now we've got Fe, again we only wrote it once, so we don't need any subscripts, but we've got a polyatomic ion that we've written multiple times. So we need brackets. So inside our brackets, we're going to have the NO3. because that's what we were writing. And then to show that we wrote it 3 times, we need our 3 outside the brackets. So that's our formula for iron 3 nitrate. All right, our final example we're going to look at is potassium sulfate. What I would like you to do is pause the video and see if you can work out how we're going to write the formula and whether or not we need brackets. All right, so the potassium ion, K+, and the sulfate ion, SO4 2-. Looking at the charges, we've got a +1 charge and a -2 charge. They don't balance out at the moment. What we need is an extra positive charge. So I'm adding another potassium ion. Looking at this, we now have 2 positive charges that can cancel out the 2 negative charges. So writing the formula for this one, K, and we wrote that twice. So we use our subscript of 2, and then SO4 we only wrote once, so we don't need to use any subscripts. Now since we didn't have that polyatomic ion multiple times, we don't need brackets for this one. So potassium sulfate is K2SO4. Tell us that we used 2 potassiums and only 1 sulfate.